In today's lecture, we are going to study chapter 7 related to retaining walls and lateral earth pressure. Just a reminder of what we have studied so far. If we start from the beginning, chapter 1 was the types of foundation, whether shallow or deep. Chapter 2, we studied shallow foundations specifically. Then in chapter 3, we studied the bearing capacity and the settlement, of course, of shallow foundations. And in chapter 4, we took one of the types of the shallow foundations, which is the isolated footings, and we studied it. Of course, there are many other types that our syllabus did not include, but there are other types. They are just applications for what you have studied here. If you study shallow foundations and you know how to design shallow foundations, then you can apply by the help of some structural data or structural analysis data how to design other types. If we have time, we may see examples for the design of other types, but we studied the isolated footings because this is what is included in your syllabus. The isolated footings for vertical and moment, or the case of moment. Then we studied problematic soils. Later, we took many lectures for the deep foundations because it is a very big subject. So we studied the deep foundations. Now we studied shallow foundations, deep foundations. Then we are now going to shift to another type, which is retaining walls. Retaining walls, it deals with the lateral load. Shallow and deep foundations we were mainly studying the vertical loads on the soil. But now we need to study something to carry the lateral earth pressure, the lateral loads within the soil, or the lateral stresses within the soil. So we need to study something called retaining wall. As you said at the beginning of the lecture, you studied last year something related to slope stability. Slope stability and retaining walls both serve the same target. Retaining wall, let's speak about slope stability, connects between areas at a higher level with areas at a lower level. How to keep them stable in place. The higher stay higher and the lower stay lower and nothing reach failure. The same we can apply in case of retaining walls. But how? Suppose that you don't have enough space to construct a slope. You don't have this on site. Why? Suppose you have a very big piece of land on the north coast, and you want to make lots of villas. So if I want to make these villas on steps, so that each villa would have a view of the seashore. So in this case, I need to have levels. How to connect the higher level to the lower level, or how to keep the higher level stable in place? I will make a slope. But if I make a slope, then I'm wasting my land, because if instead of constructing this slope, I can construct a few villas at this location. So I am losing very precious land. So in this case, I will go to a case of a retaining wall. Why? Because as you will see here, retaining walls does not consume a lot of land. It is hidden in the ground, and of course it is more expensive. So usually your first thinking is to design a slope. If you don't have a space, design a retaining wall. Similar to what we said with the case of deep foundation and shallow foundation. You always start with shallow foundation. You never start thinking of deep foundations. But in case you find that shallow foundation is not adequate, then I go to deep foundation. The same here. I will start with a slope. But if I cannot construct the slope because of usually its area limitation, then I go to retaining walls. So let's see this is the higher level here. This equipment is standing here at a higher level, and you have here a lower level. What is happening? There is a very thin wall that is carrying everything. If I want to remove this wall and make a slope, you will find that you will have a slope starting from here and going this all the way down and consuming a very big portion of the land. If you have it, use it. If you don't have it, then you have to use this retaining wall. So this is one type of retaining walls. Of course, it is a special type of retaining walls, but we will discuss this later. We're just now considering the concept. It's a retaining wall. Here in this photo, we have three types of walls in one, or three types of structures in one shot. If you look here at the back, you will find a primitive retaining wall with some blocks on top of each other, and this is a type of wall. This is a bulky retaining wall, just putting rocks on top of each other, maybe adding mortar in between or not adding mortar, and it's enough. The friction between the blocks is adequate. It's okay. But this is a bulky type. This type will be very big in dimensions. Of course, it will be much less than doing a slope, but it is, compared to other types of retaining walls, this is bulky. Here you find that this is very, very high. Compare the length of the person standing here and the length of the wall and the height of the wall. It is very, 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 very tall, but the thickness of it will be very small, because this is a special type of walls that have a special thickness. Because of the method of construction, we can minimize the thickness of the wall. So it's another type that can reach very big heights, and in the same time it's not wasting a lot of money. The other third type here, this is rock. It's existing. I did not do anything to it. It was there. This was constructed. This was constructed. But this, it was existing. It was, but I'm afraid that with time, pieces of this rock may fall down. And if they fall down with the time, the whole slope may fall. So in this case, I will cover the slope with something. This something may be a wire mesh, a geotech style mesh, or anything that would cover the slope to keep the rocks in place, to avoid pieces of rocks with time going loose and falling down. We'll see what are the application of the retaining walls. If I have a ground at this high level, and I want to make maybe a tunnel or a road at a lower level, then I can put a retaining wall to the right and a retaining wall to the left, and in between I can excavate, and I would have a retaining wall here and a retaining wall here, keeping all of this area in place. of course, what is the retained height? It's the height between the highest level and the lower level of the earth. So this is the retained height. So this is one type. Another type is more or less similar to this, but instead of just having this to retain soil behind, no, it will be carrying a load. It's something like here. This is a wall, and this is a wall, and it is carrying a bridge on top. In this case, the name changes. It is the same. It's the same application and the same function, but usually for bridges, we say the abutment of the bridge. You have to study this. Abutment is the first support of the bridge, and abutment in the other side is the last support of the bridge. In between, you may find other supports, and we call them piers. Pier. One is pier. So for any bridge, you will have abutment at the start, or abutment at one side and abutment at the other side, and in between, if you have very big spans, then you may add piers in between. This will be similar to a retaining wall, because it is actually retaining the soil that is behind, because you need this bridge to be connected to the land. So you have to have here soil. So this is another function. Now we are going to classify retaining walls, similar to what we have done with piles and footings and everything. We are going to classify them. This is, of course, you may find, as we said before, you may find many classifications. It depends on what you are classifying. I said before, if I have a class or lots of students, I may classify them boys and girls. I may classify them tall and short. I may classify them having higher marks and having lower marks. It depends on what you want to classify. So don't be confused by lots of types that you find in any textbook. It means that you have to just to go what you are classifying according to what. So you may classify the retaining wall according to the type of the retaining wall. The type, it is related to the shape of the retaining wall. So you may have something called rigid retaining wall. Rigid retaining wall may be divided into some types. The first type is called, I have here rigid. It means that I will have another type that is not rigid, but we'll discuss it later. Let's concentrate now on the rigid retaining wall. They may be gravity wall. Gravity wall, from the name, it means that it is bulky. You remember in the photo here, I showed you something here, and I said that here, this is a little bit bulky wall. This is a gravity wall, because just pieces of stones on top of each other, maybe masonry, maybe concrete, but bulk, massive concrete, or maybe the stones or the masonry units are, you put mortar in between to fix them together or to keep them in place. So gravity retaining wall means walls that are not very high, and in the same time they are bulky, because they work under gravity. It means something. It means that this wall do not carry tension. It only carries compression. When I say gravity retaining wall, it means that it's affected by gravity. Gravity is always downward. So it means that it is always in compression. The wall is always in compression. That's why I told you, you may have blocks of rocks with no mortar in between. I don't need the mortar, because it is just very massive, very big, massive, and it does not include any tension. The other type of the rigid, we said that rigid gravity. Then we have another type which is called rigid cantilever. From the name of the cantilever, it means that there is moment, and if a cantilever with a moment, then I have tension and I have compression. In this case, it will be slimmer with smaller dimensions, but I will have to add steel reinforcement because I will have moment. Moment means tension in one side and compression in the other side. So this would be a shape of the wall. This is the shape of the wall. This is the higher side and this is the lower side. And this is a very slim wall. This wall wants to move outside. What will prevent the wall from the motion? It is reinforced. It can carry tension. And if the soil tries to push the wall will resist, but will resist due to the ability to carry moment. So it will carry any amount of moment according to my design. So this is a cantilever. Another type of rigid retaining wall is called the counterfort retaining walls. This is a cantilever. There is a limitation for the cantilever. If I make, say, a retaining wall, if I want to have this height 3-4 meters, it's okay. Of course, you know the bending moment of a cantilever is always WL squared. So the effect of the L is the height of the wall will be always squared to power 2. So it means that if I have this height 10 meters, the moment will be considerably more than a wall with 4 meters. 4 meter L squared is 16, but 10 meters L squared is 100. 16 to 100, no, it's a very big difference. So in this case, there will be a limit for the cantilever wall. I cannot reach any number. 4 meters, 5 meters, 6 meters, this is maximum that I can reach with a cantilever wall. By the way, 6 meters is very high. 4 meters is a logic number. So in this case, I go to something called counterforted retaining wall. Counterforted retaining wall, it means that I am adding stiffeners to the wall itself, so that every spacing I put a web or a stiffener to prevent the cantilever from deflection. If I here at this location I add a counterfort, and here I add another counterfort, it means that by the way, the counterfort is in the opposite side. The counterfort is always in the side that you are going to add your filling material. So I will put here a counterfort, and then after say 4 to 5 meters, I put another and another and another, so I can reach, instead of having a cantilever slab, I will have a 3-sided slab. The slab will be carried in one direction on this counterfort, and in the other direction on this counterfort, and of course connected from the bottom. So it is only free to move from top. So this is another way. If I have if the height is big, in this case I will have to use counterfort. But as you see here, this is the counterfort, and this wall is constructed. Once they finish, they are going to backfill all of this area. So if you look at the wall from the other side, it's just a clear wall. The counterfort is hidden below the soil. So the counterfort is actually working. Can any one of you think, in this case, if I put here a counterfort, the counterfort will be working in compression or in tension? Usually tension, because the wall wants to go outside, and you are putting the counterfort inside. So it is pulling the wall back in place. I can only do this in walls where I will put the filling material later. I will have to construct the wall first and then put the filling materials on layers and so on. Suppose I need the opposite. What is the opposite? I have an existing soil and I'm afraid that this, or I have a slope, or not slope, high area, and I'm afraid that with time this would fall. So I'm going to build this wall, but I cannot put this counterfort inside, because to put it inside, it means that I'm going to remove the soil, build the counterfort, and then return back the soil. This is a waste of money. So I can put something outside here. So if we go to this drawing, instead of putting the counterfort in this side, I put something outside. In this case, if I put this something, it is also a counterfort, but on the opposite side, it will be called a buttress. What is the role of it? It's a stiffener. Every fixed distance, but in this case, it will be carrying compression, not tension. So in this case, these are the buttresses. But of course, these are not covered by the soil, so I will see them. So it needs architectural touch, architectural point of view, how to keep them in place, but in the same time they do not let you feel that these are very things that are not put in place, or they are not good for the site. So here they covered it with stones, here also covered with stones, putting chairs in between, trying to use a landscape that would use these buttresses as if they are needed. Maybe put some lighting in places, so that the architectural point of view changes it to be something very good for the eye, instead of being something harmful for my eye. So now we finished the rigid retaining wall. So rigid retaining wall is either bulky gravity wall, or slim cantilever wall but short, or counterforted retaining wall for high walls, but it will be in tension, or buttressed retaining wall in case I cannot put the counterfort inside and I have to put it outside. These are all rigid retaining wall. The wall is very bulky and rigid, but there is a type called flexible retaining wall. You can use another name usually, but of course it's a different classification, but more or less they are the same category. Sometimes we say a shoring system, side support system. If you want to go to a site and you want to construct a basement, you need to dig and excavate the ground and put your foundation maybe 10 meters below. How can I do this? I have to keep the soil next to me in place, otherwise it will be sloped. Suppose you are drilling a hole 5 meters by 5 meters with a depth of 5 meters. Once you finish drilling, will it be 5 by 5 by 5? No, you will have side slopes. This is usually when you go to the seashore and try to dig any hole. After you finish, you cannot find 90-degree sides. Usually the sides are sloping. I don't have this luxury in many sites. I want to construct my building and next to it there is another building. If I just dig my building, the other building will fall in my excavation. So I have to put something to support this. What will be this? I can put something, usually in Arabic we say سند جوانب, or retaining system, side support system. In this case, this system will be used for a short time. It will be used for the time of construction. Once I finished, I remove what I put, or I leave it in the soil and go to another site. I don't need it anymore because I only need it to construct some footings below and then backfill again. So I don't need it for the time span. So in this case, I'm not going to construct all of these huge construction. They need space, time, and money. So in this case, I will do something temporary. Usually we call it a shoring system or a side support system. What about this side support system? It is flexible. It means that it can move. It is not just fixed in one place. No, it can bend a little bit, but it is still safe. But I cannot do this for something that normal people are going to use it for their lifetime. But in my case, I will use it during construction. People who will be inside are workers, engineers, people who work in the construction field. So they can understand that this is a temporary structure, so it can be flexible. They can see it moving few centimeters and they do not get afraid. But if I do this with normal people, they find that it is sloping a little bit, they will say the building is going to fall and they will leave the building, so or the structure. So in this case, a flexible retaining wall or a sheet pile wall, ستاير, usually in Arabic we call it ستاير سندة or side support system or whatever you call it. So this is a system consisting of, it's either piles, concrete piles, you can do just concrete piles next to each other, one touching the other to the other, and so on, till you have a line of piles, so as if you have a wall. So in this case, it will be a flexible retaining wall. Why flexible? Because the top of this retaining wall may move few centimeters and it is still safe and it's not falling. So this is the type of a steel sheet pile wall. This steel is made of steel sections. We take these steel sections, insert them in the ground, touching each other. So once I finish, I have a line of wall. I can excavate inside and the soil outside would be in place. So this is a flexible type. Let me see. Okay, what are the forces acting on the wall? If any wall, I'm not speaking about the flexible or any wall. There are two types of water pressure. So I have water forces. Of course, there may be water within the soil. So this water will affect the wall in two things. The force resulting from the lateral earth pressure, which will be, this is what we are going to study in the next part of the lecture, is the lateral pressure of, not the lateral pressure of the water, sorry, we are going to study the lateral pressure of the soil. This is, I'm sorry, I confused it. But for water, we have lateral pressure on the, of course, water has pressure in any direction, sides, up, down, in all directions. So water pressure is in all directions. So there is uplift forces on my wall, and there is horizontal forces on the wall. So this is the part of the wall. For the soil itself, I have lateral forces on my wall, and this is what we are going to study in the next part of our lecture, which is the lateral pressure of the soil on the wall. We can stop here today and continue next time, inshallah. Thank you.